Okay, so sorry, continuing. So I have 3 times 5 and I have 5 times 1 when I broke down, right? Because we're subtracting fractions, right? That's the first thing. That's what we're doing. We're adding and subtracting fractions. So the question is, what do I need to make them the same? What do I need to make them common? Well, over here, what do I need? What's missing over here that's is over here? This one's already got a 3. What's this lacking? I should say missing. A 1, just a 1, right? That's it. It's got an extra, but what is it lacking? Lacking means you don't have it. Okay? So now over here on the other side, what is this guy lacking? A 3. So whatever I do to the top or whatever I do to the bottom, I have to do to the top as well. So that's why I'm also including it on top, because it's a fraction. It has to be equal. So if I multiply by 3 on bottom, I also have to do that on top. Okay. So I get 15 on 15 now is the common denominator because 1 times 3 times 5 is 15. Same thing over here. 5 times 1 times 3 makes 15. Okay, so 15 is the common denominator. A lot of you already knew that. You didn't have to do these steps to do that. I understand that, but today it's going to help you because the problems are going to look a little different than regular fraction problems. Okay, so that there's a reason why I'm doing it this way. So now the top also change. Well, one of them is going to change. This guy right here is 1 times 4. So that one's going to stay 4. This guy right here now is not 1 anymore. It's a 3 because it's 3 times 1 because I had to include 3 on the bottom. Okay. Now they're balanced. They're equal. The bottom is the same. So when I add or subtract, I don't even touch the bottom. I don't touch the denominator. It stays the same. All that I add or subtract are the numerators, the top. 4 minus 3 is positive 1. Done. Okay. Addition, B is the same thing. Addition is the same thing. The only step that you're going to do is you're going to add at the end instead of subtract. Okay. So 3 and 7. So first thing I'm going to do is factor the denominators. That's my step. Factor the denominators. Okay. So if I was to do a factor tree for positive 3, what would I end up with? 3 and 1. That's it. Same thing with 7, right? 7 and 1. They're prime. Okay. What is this lacking that the other one has? A 7. So I got to include a 7 here and here. And then over here, I'm lacking a 3. So now they're equal. The bottoms are equal. 7 times 3 times 1 is 21. 7 times 1 times 3 is 21. The top here, now it's 7 times 1, which is 7. So the first one's going to have a numerator of 7. The second one is going to have a numerator of 2 times 3, which is 6. Okay. Add or subtract the tops. The bottom stays the same. Simplify or reduce if you can. So 13 over 21, can I reduce that fraction? Nope, because 13 is prime. The only thing that goes into 13 is itself. Okay. So I might have done those problems differently than you've done them in the past, but trust me, these steps are going to help you with the ones you see today and then the ones you see next week when we do our part 2 lesson. Okay, this is part 1. So first thing we're going to do is we're going to factor the denominators, factor the bottom. Break them down as far as you can. That'll help us with these 2 steps. What's missing, what's needed, and what's missing from each to make them equal. And then add or subtract the bottoms only. And then if we need to, we can reduce or simplify. Okay. All right, so 2a. It's two fractions being added, right? It's two fractions being added. It hasn't changed. But now it's a monomial because this one's got an x with it. This one doesn't, but the one on the left has an x with it. Okay, so let's break this down. 5. If I were to do a factor tree for 5, I would just get 5 and 1, right? And then how do I break down x cubed? It's a monomial. That's how we break it down, right? This is not a binomial, so we can't use the steps, binomial steps or trinomial. It's not a binomial or trinomial. It's a monomial. It's only got one term. Same thing with 2. 2 is just 2 times 1. Okay. Now, my questions are, what are needed for them to be balanced? What's missing for them to be the same? Okay, so let's start with the left side. What is this missing? A 2. The 2 is over here. So I got to add, include. I say add, but I don't mean add because we're not adding here. We're multiplying actually. Okay. Over here, I'm missing quite a bit. Over here, I'm missing quite a bit. What's the first thing I need? A 5. I need a 5. And then I need 3 x's, right? So since I didn't have them, I have to include them to the bottom and to the top. Anything I need to include to the bottom and to the top, both. Okay. So now the bottom, the numerators should both be the same. 2 times 5 times 1 is 10. 2 times 1 times 5 is 10. And they both have x to the third power. Okay. So now the numerators, the tops. So I had to include a 2 over here. So it's 2 times 3 now, which is 6. Over here, I had to include quite a bit. I had to include a 5 and 3 x's. So if I multiply, first of all, if I multiply 1 times 5, I get 5. And then I have x to the first, second, third power. Okay, so the common denominator now is 10x to the third power. The top, I have to add them. Can I add them to make 11? 6 plus 5 makes 11? No, yeah, because they are not like terms. So how do I write them? I just write them the way they look. 6 plus 5, x cubed. Oh, you mean over here? So why wouldn't I over here? Oh, because this guy already had this, right? This guy had this. I need to make them balanced. So I only include what I need to make them balanced. So over here, this was missing, before this was missing a 2. So that's why I included a 2. Everything else it had. This guy over here was missing a 5 and 3 x's. So that's why I included it. It's only include what they're missing. Okay? Yeah. If it already has it, you don't need to include it. If it doesn't have it, include it. But just include it to the top as well. Okay, so my next question. Can I do this? Cancel those out. They're no longer x cubes because I got an x cube on top and an x cube on the bottom. Can I do that? Yeah, the answer is no. I cannot do that. Why not? Exactly. This guy's a lone wolf. This guy is not a lone wolf. It's a binomial. Okay? If they were both lone wolves, if they were like this, no more 6, then yeah, go for it because they're both lone wolves, right? But because they're not, I can't do that. The bottom is, but the top is a binomial. Okay? So Therefore, I can't do anything. I'm done. Okay. Alrighty. Okay. So now the bottom here. Subtraction now. First step. Always factor it down denominators. What does 25 break down to? 5 and 5, right? 5 and 5. X squared is just x squared. X times x, right? They're both monomials, so that's how I break them down. 5. 5 is just 5 times 1. What's lacking? So what is this guy missing over here? Just a 1, right? This guy doesn't have much. This guy has a little more. But he's missing the 1. So I'm going to include a 1 here, and I'm also going to include a 1 there. This guy over here is missing quite a bit. What's this lacking that the other one has? It needs another 5, good. It needs another 5, so another 5, and then it needs 2 more x's, right? Okay. So now the bottoms are the same. 1 times 5 times 5, or 5 times 1 times 5. Either way you multiply it, it's going to be 25. And either way you multiply it, it's going to be x to the second power, because they both have the same now. The top. This is 1 times 1, so that stays 1. Over here I have 5 times 1, 5, x to the second power. Okay, so now the bottom stays the same, 25x squared. Now I have a 1 minus 5x squared. Can I subtract those to make negative 4? No. Can I do this? No. For the same reason I couldn't do it, I can't do this for the same reason I couldn't do it on the last problem. The top is a binomial, the bottom is a lone wolf. It's a monomial. Okay. All right. Okay, so now flip it over or open it up and look at C. Okay, this one doesn't have any numbers. Doesn't have any coefficients like the others did. 1, 25, whatever it was. But it does have x's and y's. And they are both monomials. Even though this one has 2 letters and this one has 2 letters, they're monomials because there's no plus or minus in front. If there was a plus in between here, then it would be a binomial. But it's only one term. So how do I break this down? Well, it's got x times x and y times y times y. This one's just x times y. Okay. Equal, make them balanced. Is there anything this guy's lacking? No. Over here, I have 2 x's and a y. I got 2 x's and a y, and in fact, I got more. More is okay, but they have to be at least equal. This guy over here is missing a little bit. What is this guy missing? 2 y's. So we're going to put a y here and a y here. Also put them on top. Okay, so now the bottom is x squared, y cubed. X squared, y cubed. Top. Well, the first one, the first numerator right here, didn't get anything included, right? It didn't have anything included here. So it's just going to stay 1. The bottom, or the other one, though, had 2 things included. So that one needs a y squared. Okay. So we got a 1 plus y squared, and then we have an x squared y to the 3rd power. Oh yeah, in front of it. So you have a 1 here. Yep, that's fine. It's actually there. We just don't write it. But so if you do write it, it's not. It's correct. It's still correct. Okay. All right. Okay. So now let's look at 3a. So this is a binomial and a binomial, right? It's got 2 terms, 4x and positive 9. They both have that. So do we have a GCF? Is there? So we have to factor them using the rules on the board. So is there a GCF here and here? Can't divide it by 4. Can't divide it by 2. But what do you notice about both of them? They're the same. Guess what? They did step 1, step 2, and step 3 already for us. That's what happens when they're already the same. They've done the first 3 steps for us already. So let's write that down. Okay. Now the top we need to add. So we got a negative 3x squared, and then it's a minus a negative 4x squared. Be careful with the signs. The signs matter. Now the numerator, the top, aren't these like terms? They're both x squareds, right? So I can actually combine, add them, or subtract them. Well, I have a negative plus or minus a negative. That actually means plus, right? Double negative. So when I combine them together, I'm actually going to subtract them, and it makes 1x squared. Okay. Hmm? Okay. Alrighty. All right. Okay. Letter B. So 3B. They're not the same. They're close. One's a 6 and one's an 8, but they both have an x. So they're close. So if they're not close, we got to start with step 1. So factor them all. So 6 is 3 times 2, right? 3 times 2 times x. 8 is 4 times 2, but 4 can still be broken down. So we want it broken down all the way. So it's 2 times 2 times 2, right? That's 8. Because you have to factor them all the way. If you don't factor them all the way, it won't work. Okay. So now I got to see what's lacking. This guy over here. Let's see. Looks like I got an X, I got a 3, I got a 2. What am I missing over here? 2 more of them, right? Yeah, 2 more of them. So I got to include 2 more over here, and then 2 more over here. This guy over here is almost there. What's it missing though? A 3. Yep, it needs a 3. Okay. So now the bottom is 2 times 2 times 3 times 2, or 3 times 2 times 2 times 2. Either way, you're going to get the same number. That's 24, and then an x. Okay. The top. The top is 2. The first one, the first numerator is 2 times 2 times 7, which is 28. The next one is 3 times 3, which is 9. Okay. Over here, if you look, they're both like terms. 28 minus 9. I can actually subtract those. When I subtract 28 minus 9, that gives me 19. I can actually subtract those because they're like terms. Last step, simplify or reduce if we can. Can I reduce 24 and 19? No. Nothing can be divided by both. 19's prime, I think, so. Okay. If I needed to, I could, because they're both monomials. Okay, there's no one of them's, and they're both lone wolves. If I could, but I can't because nothing goes in evenly except for one. Okay. All right. So last thing, we got about 15 minutes. I want you to do C and D, the last two. C and D on the last page. The very last page, I want you to do C and D. We will do them together in about 5 minutes or so. Okay. So go do C and D, and then we'll do it together. I want you to see if you can do them, and then check your answer when we are after you're done. Okay. Okay. All right. So let's take a look at these. Let's see. So C, we break down 4. It's 2 times 2 and then x. And we break down 4 again, 2 times 2, and this one has 2 x's. So they're pretty close. The only thing that's missing is one guy needs this guy needs another x. Okay. So the common denominator is going to be 4x to the second power. This guy needs a 7x and this guy is a 5. Add the top. Well, I can't add them to make 12 because one is a one has an x and one doesn't. Done. Okay. The last one, letter D. Wait, is there 2 letter C's? Nope, there wasn't. I did it right. Okay. Letter D. 9 and 3. 3 times 3, 3 times 1. Again, pretty close. This guy needs the first one needs a 1, and the second one needs a 3. So I got to include a 1 up here, and I got to include a 3 over here. So now they both make 9. And 4x and 21. Okay, add the top. Done. Okay. All right. Okay, so tape. Look behind you. I think there's some tape on the desk already. If not, there's tape at the back. Tape and then pass it forward. And then I think there's one row that doesn't have tape, so make sure you get that to them so everyone can tape.